All right, today we are cracking the code on one of the oldest and, honestly, simplest forms of encryption in history. We're going to see how just a tiny shift of the alphabet can hide a message right out in the open.
So let's just start with this thought. What if that's all it took? What if, to make a secret message, all you had to do was slide the alphabet over a few spots?
I know, it sounds almost too easy, right? But believe it or not, this one simple idea, just sliding the letters, is the core of what we're exploring today. And this was a real cipher used for centuries. Now, this method isn't just some random idea. It actually has a name, and it's a pretty famous one, the Caesar Cipher. So let's break down what that really means. The Caesar Cipher is one of the very first encryption techniques we even know about. It's a type of substitution cipher, which is really just a fancy way of saying we swap every letter for a different one. The key, and I mean that literally, is that every single letter is shifted by the exact same number of spots down the alphabet.
For instance, if we pick a shift of 3, well, A becomes D, B becomes E, C becomes F, and you just keep going like that for the entire alphabet. It's a super consistent, totally predictable pattern.
But, that predictable pattern is completely useless without one crucial piece of information. And that brings us to the most important part of this whole thing, the key. And what's so cool about this is how simple the key is. It's not a physical key or a complicated password. Nope, the key is just a number. It's the secret number of spots you shift each letter. If you know that number, you can lock and unlock any message you want. It's the only secret you actually have to protect. So, for the rest of our explainer, we're going to use a key of 3. It's the classic example, and honestly, it makes it really easy to see what's going on. So remember that. Our secret number is 3. Okay, theory is great and all, but let's actually see this thing in action. We're going to take our key and we're going to encrypt a message step by step. So here's our setup. The original message, what we called the plain text, is the word hello. And our secret key, like we just said, is 3. The goal? Turn hello into something that looks like complete gibberish. All right, let's do this letter by letter. We take H, we shift it forward 3 spots, and we get K. Easy. Then E plus 3 spots, that gives us H. L shifted by 3 becomes O. The second L, well, it also becomes O. And finally, O plus 3 letters down the line lands us right on R. And there it is. That's our result. By applying our key of 3 to every single letter, our plaintext hello is now the encrypted ciphertext KHOOR. Okay, awesome. We've hidden our message. But what about the person on the other end? How do they read it? Well, that's where decryption comes in. And thankfully, it's just as easy. And the best part? There's no new complicated math. To get the original message back, you just do the exact same thing, but backwards. You just reverse the shift. So instead of sliding the alphabet forward by 3, we're now sliding it backward by 3. We're subtracting our key instead of adding it. It's that simple. Let's just test it to be sure. We take the first letter of our secret message, K, we shift it back 3 spots. And where do we land? Right back on H, the first letter of our original word. It works perfectly. Now at this point, you're probably thinking, hang on, this seems a little too simple to be safe. And you know what? You'd be right, today. But we have to remember to look at this cipher in its own time. See, back when this was invented, its biggest strength was that simplicity. It was fast, you could do it by hand, and your enemies didn't have computers. But today, those same things are its biggest weaknesses. There are only 25 possible keys to try. A modern computer could check all of them in a fraction of a second. Plus, all the letter patterns from the original language, they're still there. This brings up a really important question that a lot of people have when they first learn about cryptography. If everybody knows how it works, that you're just shifting letters, how can it possibly be secure at all? And the answer gets to the very heart of how all cryptography works. The security was never about hiding the method. It was always about hiding the key. You could tell the whole world how you were encrypting your messages, as long as the by how much, that secret number was kept private. So let's just do a quick recap of the big takeaways here. First, the Caesar cipher just swaps letters using a fixed shift. Second, that shift number is the secret key. And third, while it's a fantastic way to learn the basics, it is absolutely laughably weak by today's standards. Now, we kept this intro pretty focused on purpose. We didn't get into the nitty-gritty of how you'd break this cipher, using attacks like brute force or something called frequency analysis.
And we definitely didn't touch the principles that make modern encryption so powerful. But don't you worry, we'll get there.
And that leaves us with a really interesting thought to end on. The biggest weakness here was that the shift was always the same. It was fixed. So, what happens when the shift isn't fixed? Next time, we're going to look at another substitution cipher that takes that exact idea and cranks the complexity way, way up.